Welcome to True Projects. In this video, we are going to discuss about the project title, which is Sentiment Analysis of Tweets Related to SUS Before and During COVID-19 Pandemic. The project's significance lies in its response to the need for analyzing public sentiments towards the Brazilian Unified Health System, which is SUS, amid the COVID-19 pandemic. It deals into the evolution of public perceptions and emotions concerning of SUS both before and during the pandemic. This endeavor holds immense importance for policymakers and healthcare experts as it equips them with the means to gauge public sentiment, detect pertinent issues, and make well-informed decisions. Through the application of machine learning models to Twitter data, the project provides valuable insights into sentiment trends, potential concerns, and the overall satisfaction level regarding SUS. These insights pave the way for more responsive and effective healthcare policies, enhancing the healthcare system's adaptability and impact. The project's core objective is to harness the capabilities of diverse array of machine learning algorithms which are name-based, random forest, XGBoost, AdaBoost, K-nearest neighbor, decision tree, support vector machine, and MLP. These algorithms are employed to conduct a comprehensive analysis of dynamic sentiment shifts within the public regarding the Brazilian Unified Health System, which is SUS, both before and during the COVID-19 pandemic. This project's overarching aim is to unearth evolving sentiment trends, pinpoint areas of concern, and gauge levels of public satisfaction by analyzing Twitter data. These insights derived from this analysis serves as valuable tools for policymakers and healthcare professionals, facilitating more informed decision making and the enhancement of healthcare policies in Brazil. Coming to requirements, we need hardware requirements. In that, operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to implement the project. The first one is importing the packages. This module involves importing necessary Python libraries and packages, which are Pandas for data manipulation, NumPy for mathematical calculation, NLTK for natural language processing, sklearn for machine learning, Seaborn and Matplotlib for visualization. Next one is exploring the dataset. In this step, we examine the dataset to understand its structure, size, and content, which is crucial for data pre-processing and model building. The next module is visualization. This module involves creating various visualization representations, which are graphs and charts, to gain insights from the data, such as trends, patterns, and correlations. Next one is data cleaning. Within this step, we have tokenization and stemming. Coming to tokenization, it is a process of breaking down a text into individual words or phrases or tokens. It is used to convert textual data into smaller units for further analysis. In sentiment analysis, it helps in preparing text data for feature extraction and model training by separating words or phrases. Coming to stemming, it is a process of reducing words to their root or base form. Stemming is applied to the text data to standardize word forms. It helps in reducing variations of words to their common base, which can improve the efficiency of text processing and feature extraction. Next one is word list. It is a collection of unique words present in dataset or corpus. A word list is often created to understand the vocabulary used in the dataset. It can be used for various purposes, including feature selection, analysis of word frequency, and building word clouds or visualizations. Next one is bag of words. Bag of words is a text representation technique that converts text data into numerical vector, where each word's frequency in the document is used as feature. Bag of words is used to transform text data into a format suitable for machine learning models. It represents text as set of features, allowing for the application of classification algorithms. Coming to the next module, which is splitting the data into train and test. Splitting the data into train and test, which means dividing dataset into two subsets, one for training the machine learning models and other for testing their performance. Coming to next one, which is building the model. This module involves implementing various machine learning algorithms. First one is name-based. It is a probabilistic classification algorithm based on Bayes' theorem. It assumes that features are conditionally independent given the class. It is employed for text classification tasks like sentiment analysis because it's computationally efficient and works well with the high-dimensional data. Despite such simplifying assumption of feature independence, it is often delivers competitive results in practice. Coming to random forest classifier, it is an ensemble learning method that builds multiple decision trees during training and combining their predictions for improved accuracy and robustness. It is utilized for its ability to handle both numerical and categorical data. It reduces overfitting and provides feature importance scores, making it valuable for understanding which features contribute most to sentiment analysis. Next one is XGBoost, which is extreme gradient boosting. It is a gradient boosting algorithm known for its speed and accuracy. It builds decision trees sequentially, each correcting the errors of the previous ones. It is chosen for its high predictive power and ability to handle complex structured data. It is widely used in competitions and real-world applications, offering robustness and efficient model training. The next algorithm is AdaBoost. It is adaptive boosting. It is an ensemble learning method that combines multiple weak learners to create a strong classifier. It is used to improve the performance of base models, making it particularly valuable when we want to boost the accuracy of sentiment analysis predictions through a combination of simpler models. The next one is K-neighbor classifier. The K-neighbor classifier assigns class labels to data points based on the majority class among their K nearest neighbors. It is versatile and it can be applied to various classification tasks. It is chosen when exploring the influence of data locality on sentiment prediction. The next one is decision tree classifier. Decision trees are models that make decisions through a tree-like structure of if-then-else conditions. Decision trees are interpretable and capable of capturing complex relationships in the data. They are used to understand how specific features contribute to sentiment classifications. Next one is support vector machine. It is a binary classification algorithm that aims to find the optimal hyperplane to separate the data into different classes. SVM is effective for both linear and non-linear classification tasks. It is chosen when we need a powerful and flexible model for sentiment analysis. Coming to next one, which is MLP, which is multi-layer perceptron. It is a type of artificial neural network with multiple layers of interconnected nodes. It is used for its ability to learn complex patterns in the data. It is applied when the sentiment analysis tasks require capturing intricate relationships in text data. Coming to the next module, which is training the model. Each of the models created in the previous step is trained using the training data set to learn patterns and relationships in the data. Next one is Flask framework with SQLite for sign up and sign in. This involves setting up a web application using Flask and SQLite database for user registration and authentication. Next one is user input. User provide text input through the front end, which is then passed to the trained models for sentiment analysis and prediction. Coming to the next one, which is trained model is used for prediction. In this, the trained model will be used for prediction purpose. The last one is final outcome displayed through front end. This predicted sentiment, which will be positive, negative or neutral, it is displayed through the web interface, allowing users to gain insights into sentiment for input text. Coming to the comparison graph, here on the x-axis we have the accuracy scores and on the y-axis we have the algorithm names. Here we can see the accuracy scores of each particular algorithm. Among all the algorithms, MLP, XGBoost and Random Forest are performing well. In that, Random Forest is having the higher accuracy. Coming to execution, we need to open the code folder. This is the code folder of the project. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes the code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And these two are the model files, which contains the algorithm information which will be loaded into the project code during runtime. This is the notebook.ipynb file. This is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it popular choice for data science. This is the sign-up file. This file is the database file used to store the user information. Now we need to copy path of the code folder from the address bar of the file explorer. So I will copy the path. Now we need to open the Anaconda prompt. Here, we need to use the cd command followed by the space and then paste the copied path. This command will change the current directory to the code folder's path. Now I will click on the button enter. So the code folder, the path is changed to the current code folder. Now here we need to type python space app.py. This will compile app.py file using the command which is python space app.py in the Anaconda prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we will click on the button enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is this one, and the port number, which is this one, unless configured differently. Now we will copy this local link provided by the framework and paste it in any browser. So I will copy this link. I prefer Google Chrome. So here I'll paste the link and click on enter. So this has redirected to the home page of the project which is displayed in the browser. This is the front end built using the Flask framework. So this is the web page. Now we need to click on this. Here we have the two options which are home and sign up. Now we will click on sign up. Here we need to give all these details if we are registering newly. I have already registered, so directly I'll click on the button sign in. So here I need to give my credentials. Here I'll give my username and password and click on login. So this has redirected to the home page. Here we can see sentiment analysis of tweets related to SUS before and during COVID-19 pandemic. So here we need to give input message which is in text box. For that input message, it will predict the sentiment of that particular message. So here I'll give the message. I entered the message here and now I will click on predict. So for that text, it is predicted that the label type which is the tweet type is love. Now we will try with the other message. So here I will enter the other message. I entered the message here. Now I will click on predict. So for this message, it is predicted that the tweet type is anger. Now we will try with the other text. I gave the input message and click on predict. Here for this message, it is predicted that the tweet type is sadness. Now I will give the other input message. I gave the other input message and now we will see what will it predict. So it has predicted that the tweet type is surprise. Now we will give the other message. So here I gave the other input message and click on predict. So it has predicted that the tweet type is fear. Now I will give the other input message. I gave the other input message and click on predict. So it has predicted that the tweet type is happy. In this way we can give any other message for that particular message. The web page will predict the sentiment of that particular message, which are happiness, sadness, love and anger. We will log out. Click on sign out. The project's successful achievement of its objective demonstrates the power of machine learning in analyzing public sentiment. Through Twitter data, we discern significant insights into how the Brazilian Unified Health System, which is SUS, is perceived by the public, especially in the context of ongoing COVID-19 pandemic. The identified shifts in the sentiment patterns shed light on key areas of concern and satisfaction within the population. Such information is invaluable for the healthcare policymakers, equipping them with the data-backed insights into enhance healthcare policies and address public sentiments effectively. As the global impact of COVID-19 endures, This project stands as a timely and essential tool for gauging and responding to the evolving sentiment surrounding healthcare services.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.